This is question number 16. Build up your understanding from magnetic effect of current from the book Pathfinder. So let us see what is the question. Question is, there's a small ball of mass 1 kg and charge q equal to 2 microcoulomb. It is falling vertically with a terminal velocity of this in a viscous liquid. After a uniform and constant horizontal magnetic field is applied, it is observed that the ball acquires another terminal velocity and power dissipated in the viscous fluid becomes eta equal to 0.5 times of the power dissipated prior to the switching on the magnetic field. Then we have to find out at what maximum value of magnetic induction is this possible. And it is given the dependence of this viscous force on the velocity is unknown. So that means we can't assume any type of viscous force. We can't assume linear variation of viscous force with the velocity or quadratic or any other variation. So that is unknown. And so let us see how do we solve this question. Here I have drawn the initial diagram when there is no magnetic field. This is falling. And since the ball is very small, I am neglecting the buoyancy force. Its volume is very, very small. So buoyancy force is neglected. So this is the gravity and this is the viscous force Fv. Fine. Now, finally, what happens since magnetic field is applied in horizontal direction. So I have applied magnetic field like this, right? So this means that it is, no, see here, this is the vertical direction, fine. So if this is a vertical direction, this dot magnetic field is still horizontal, right? I think you're able to imagine also. So the container is falling vertically downwards, and then this magnetic field is container to the perpendicular to this container. So this is still horizontal. This is vertical direction. So if you apply the magnetic field here, imagine what happens just after switching on the magnetic field. Velocity was in this direction, so use left hand rule. Velocity downward magnetic field, and then it will apply your force in this direction, right? So this will start. Initially, it was moving like this. Let's understand here. Initially, it was moving like this. The magnetic field is this way. Then the force due to magnetic field is this way, right? Gravity is already acting here, and viscous force was acting upward. But since magnetic force is in this direction, it will acquire a velocity component here also. So it keeps moving. Suppose at some instant, what happens? All three forces become, or all three forces balance each other. Then only it will attain another terminal velocity. Terminal velocity means velocity is constant. So velocity is constant. That means net force on the ball should be zero. So somewhere here, when velocity was like this, magnetic field is definitely perpendicular. And this is viscous force, new viscous force, Fv prime, I have assumed. Mg remains as it is, right? This angle is 90 degree because the Fv prime, which is the new viscous force, is perpendicular to the, is opposite to the velocity, and the magnetic force is perpendicular to the velocity. So this is 90 and this is also 90, fine. So I hope up to this point it is clear. So here I have written, let us assume Fv equal to 0 because it is written, it is a very small ball. Now, initially, without magnetic field, if you apply work energy theorem, then what's happening? This is due to viscous force, there is some dissipation of power, right? Heat is generated. But since it is moving with terminal velocity, its speed is not increasing, so its kinetic energy is not increasing. That means work done by all the forces is equal to 0, or power delivered by all the forces is equal to 0. So the power delivered by mg, this should be exactly equal to, right now the velocity is v. So before switching on the magnetic field, let us say velocity was v. So power delivered by mg was mg into v, f into v, right? And power delivered by the viscous forces minus times f in fv, right? Because velocity and viscous force both have 180-degree angle. So this is a magnitude, and those both magnitudes should be equal. Then this is equal to this. This is positive power. This is negative power. That is how net power supplied is 0, and its kinetic energy is not increasing. Now, finally, what happens? Finally, the power, again, same equation will be valid finally also, because the magnetic force never supply any power. Magnetic force is always perpendicular to the instantaneous velocity. So it does not do any work on the particle. So here also this equation is valid. Power supplied by the gravity is equal to power dissipated by the viscous force. So let us see, that is what I have written here. Power generated by the magnetic force is equal to 0. Now in this diagram, what is the power supplied by gravity? F dot V. Power is F dot V. So mg V cos theta. So that's what I have written here. Mg V1 cos theta, because new velocity is V1, suppose. So mg V1 cos theta. This is equal to new viscous forces Fv prime into V1, right? Viscous force is opposite to the velocity. So this magnitude is Fv prime into V1. This is new equation. Now what's given in the equation? That new power dissipated by viscous force is eta times the old power dissipated by the viscous force. So I've written this equation, whatever is given in the question. After that, I have just solved it. How? So mg v1 cos theta, this term is equal to this term, right? And this is equal to this. Fe into v is equal to mgv. So just I have substituted from all these three equations and I got this. So from here, mg cancels, you got v1 cos theta is eta into v, right? Now, another equation is, from this diagram, you can see that if I resolve forces in this direction, see carefully in this direction, then what's the component of mg in that direction? Component of mg in that direction is mg sine theta. What's the component of viscous force? No component of viscous force. This is because this angle is 90 degree. So Fb, which is the magnetic force, is equal to mg sine theta. This is what I've written. And Fv is equal to QEB sine theta. Theta is 90. So here this is QE1b and mg sine theta. Now magnetic field I have found, substituting this value of V1. So you see now the sine theta cos theta, this is eta multiplied and divided by 2. So you get mg sine 2 theta by 2. You have to find out the maximum possible field. So maximum possible field will be when sine 2 theta is equal to 1. So this is the maximum possible field, right? So that's it. That's the answer. But it is a very important question for JEE Advanced because you have to think a lot in this. And before writing the equation also, you have to think that in what scenario this is possible. So little bit of calculation is also there and little bit of visualization is also there. So it makes it a perfect question for JEE Advanced. So that's it. That was my analysis. If you have liked this analysis, please like this video and please subscribe this channel also. Thank you very much. I'll see you in next video.